for all values of x, f of x is equal to x plus 1 squared, and g of x is equal to 2 lots of x minus 1. Part A, show that g f of x is equal to 2x times x plus 2. So this is saying to substitute the f function into the g function. So substitute this f function into the g function there. Now, quite a few brackets going on here. So what I'm actually going to do, before I do any substitution, I'm actually going to expand these brackets out just to try and make my life a little bit easier, hopefully. So expanding the brackets on the f of x first. X times x is x squared. The x times the 1 is x, with 2 of them. And the 1 times the 1 is 1. And let's expand the brackets on the g of x as well. So 2 times the x is 2x, and the 2 times the 1 is 2 times the minus 1 is minus 2. Right, and like I said, we're going to substitute the f of x function into the g of x function. So 2 lots of the x squared plus 2x plus 1 minus 2. Expand those brackets. And we notice that the 2 and the minus 2 will cancel out. So we just get 2x squared plus 4x. And note here that I can factorise this. Both of these terms have got a 2x inside them. So factorise 2x outside. 2x times x gives 2x squared. And 2x times plus 2 would give the 4x. And that's what we needed to show for part A. Part B wants us to find g inverse of 7. So I want to substitute 7 into the inverse function. So let's find that first of all. Remember that g of x is this. I'm deliberately choosing the g of x that's got had the brackets expanded already, just to make my life a little bit easier. So g of x says to times by 2 and then subtract 2. So the inverse of that will be to add 2 and then divide by 2. So if we substitute 7 into that, 7 plus 2 is 9. 9 over 2 is 4.5.